So, as this week's team lead, it was given in the discussion board that 6% of Democrats would switch to Republican and 7% of Republicans would switch to Democrat. It is also known that it starts off with 30 Democrats and 70 Republicans, so we can make a state transition diagram. And the state transition diagram shows how the 6% of Democrats move towards the Republicans and the 7% of Republicans move towards the Democrats, while 94% of the Democrats stay as Democrats and 93% of Republicans stay as Republicans. With this, we can create a recursive equation that shows up as dn plus 1 is equal to 0.94 dn plus 0.07 rn, and rn plus 1 is equal to 0.06 dn plus 0.93 rn. And we can go ahead and just put that into a matrix equation right away. It's pretty simple. All you have to do is take out the coefficients in front of those variables and put those variables into their own little vector. When solving for the numbers, or the amount of people in the Democrat state and then the Republican state, we can use the equation x subscript t is equal to the matrix A raised to whatever power or whatever week it is times the initial state. In doing so, we see drastic changes in the beginning, but as it gets towards 20 weeks, we end up seeing the Democrats only change by 2.37 and the Republicans only change by 2 point something as well, not very much. And in the long run, it appears that it eventually does reach a steady state of the Democrats being 54 and the Republicans being 46. When putting the vector equations into GeoGebra, we can kind of see the computations that we got from the equations that we just did. It rotates quickly but soon begins to slow down. As you can see, the last two vectors, the vector for x equals 15 and x equals 20, are not too far away from each other, and if we kept going, eventually it wouldn't be too far away from x equals 20. And for part 2, we are starting with the givens again. We are given the equation, or we are given that there are 6% of people that are in the rural population that move to the urban population, and 7% of people in the urban population that move to the rural population. But there is a variable entering the system this time, which would not make it closed, and that is the 0.1% of urban population being birthed, as well as the 0.15% of the rural population being birthed. And in the second equation, the 1.03 plus 0.06 and the 0.07 plus 1.09, that simply just works together because we're talking about percentages of the population, so we can combine like terms, not like percentages. We can combine like terms together to be able to come up with the recursive equations again. And same process as last time. We go ahead and put those into that matrix equation, and we can use the same equation, x subscript t is equal to the matrix A raised to the power of t times the initial state. In doing so, we end up seeing an increasing amount of numbers as it goes on, and that's because of the amount of people entering the state. And whenever we go to graph it into GeoGebra, it looks like one straight line, and this would be due to there's no change in direction but rather change in magnitude because of the people entering the system and no people leaving it. After comparing the rural to urban population, we ended up getting close to a percentage, or not percentage, but a ratio of 0.59. And this kind of, in a way, indicates the slope, which after this we could also indicate one of the eigenvalues or the eigenvalue vectors, which we could computate for a diagonal and find whatever eigenvalue is higher. And so we ended up getting a slope of 0.59, and yeah.